You clicked because you heard a language model running on a Game Boy Color. That is exactly what happened, and the stakes are far higher than a retro gaming trick. We are witnessing the moment where artificial intelligence stops being a cloud-dependent luxury and becomes a privacy-first standard running on hardware you already own. By the end of this, you will understand why the race for massive models is losing to a quieter revolution in inference efficiency. Imagine a world where your personal data never leaves your device. No cloud server processes your messages, no third party analyzes your thoughts, and no latency plagues your interaction. This is the promise of edge AI, but for years it remained a theoretical dream trapped in academic papers. The barrier was always thought to be raw power. We assumed you needed massive GPUs and gigabytes of RAM to run anything resembling a modern language model. That assumption is now being dismantled by a project that defies every conventional rule of hardware engineering. Maddie Reese, a developer and researcher, managed to run a quantized Tiny Stories 260K transformer model directly on a stock Game Boy Color. This is not a modified device with a custom processor or a wireless expansion pack. It is the original 1998 hardware, powered by the same Sharp SM83 CPU that has been sitting in millions of living rooms for decades. The achievement is not just about nostalgia. It is a critical proof of concept that proves inference efficiency can supersede raw model size as the primary constraint for deploying intelligence on edge devices. To understand why this matters, we must look at what the Game Boy Color is actually doing. The system is executing a 5-layer transformer with 64-dimensional vectors. It is running attention mechanisms using rotary positional embeddings, a technique usually reserved for high-end research clusters, all while performing integer arithmetic on an 8-bit processor. The model fits within the constraints of the cartridge's static random access memory, using that limited storage for key-value caching. This is the kind of optimization that standard Hugging Face pipelines simply cannot achieve. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Here is the thing that most industry analysts miss. The success of this port demonstrates that the industry's reliance on cloud-centric large language models is breaking down. The constraints of latency and privacy are forcing a re-evaluation of how we design hardware and software together. We are moving toward a future where models are architected specifically for constrained, non-GPU environments. The Game Boy Color proves that complex attention mechanisms are viable on severely limited systems without any hardware modification. However, we must be clear-eyed about the current reality. This is a proof of concept, not a consumer product ready for the shelf. The project relies on unoptimized C-based matrix multiplication, which results in excruciatingly slow generation speeds. If you try to generate a sentence, you will wait seconds for each word. Furthermore, the heavy quantization required to fit the model into the tiny memory footprint means the output is often incoherent. The machine is thinking, but it is stumbling over its own words. This reveals a significant trade-off that the industry must resolve. While the technical barrier to entry for local inference is lowering, we still face the speed-accuracy paradox. The current benchmark shows that we can run these models, but we cannot yet run them well. The gap between this research experiment and a production-ready edge AI solution is closing, but it is not yet bridged. The immediate implication is that widespread adoption hinges on solving this latency and quality issue before this efficiency model can replace cloud-dependent solutions in consumer products. The deeper insight here is that the future of edge AI depends less on architectural novelty and more on the maturity of compiler toolchains. We need quantization-aware training and specialized inference engines that can map heavy compute graphs to heterogeneous, low-power processors. Standard pipelines are insufficient for true edge AI. Engineers must strip away training overhead and leverage specialized memory management to achieve sub-second latency. The Game Boy Color port uses on-device byte pair encoding to handle text processing, a technique that allows the system to compress vocabulary without needing a massive lookup table. This shift validates a prediction that we will soon see 9 billion parameter models running on edge devices. The gap between research and production is narrowing because the focus is shifting from model size to inference efficiency. We are seeing the birth of a smaller, smarter architecture for privacy-first devices. The Game Boy Color is the ultimate symbol of this shift. It shows that you do not need a supercomputer to run intelligence. You need smart engineering. The failure mode of running complex transformers on such limited hardware highlights that the industry must prioritize algorithmic optimization over mere portability. Just because a model fits on a device does not mean it is useful. The path forward requires us to stop chasing parameter counts and start optimizing for the specific constraints of the hardware. This is where the real work lies. It is in the custom kernels, the memory bandwidth optimization, and the integer arithmetic that allows a 20-year-old chip to perform modern neural network operations. This case study serves as a critical evidence point that edge AI has transitioned from theoretical research to tangible hardware reality. The ability to execute a transformer on a Game Boy Color is not a party trick. It is a signal that the era of cloud-only AI is ending. We are moving toward a landscape where data never leaves the device, where privacy is baked into the silicon, and where intelligence is distributed across billions of low-power endpoints. The technology is there. The question is no longer if we can do it, but how fast we can make it practical. The implications for the industry are profound. Career specialization in embedded machine learning and low-power inference optimization is becoming one of the most critical skill sets of the next decade. As we move away from the cloud, the demand for engineers who can squeeze performance out of constrained hardware will skyrocket. The Game Boy Color is just the beginning. It is the proof that the physics of computation allow for this shift, and the software is finally catching up to the hardware. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.